Hi everyone, I hope you're having a wonderful day. So today's going to be a little bit different for our fifth day of Advent of Code. Instead of going over step by step and solving the problem myself, I'm actually going to go over a problem I pre-solved, and I've already actually solved the solution for this part one. But I think this will be just a bit quicker and easier for me as I'm out and about for work, so I could only do this in a short period of time today. So let's look at the problem that we have. We have an almanac that is which is our input, which has a list of lots of different things that we need to have as our input. So the first thing is in our list is a list of all the seeds. So in our case, we have 4 seeds. In this case, it could maybe potentially be X number of seeds as well. And then each other line, we have these maps of these seed to soil calculations. In specifically that I wanted to cover is kind of some of these examples down here, where if we look at the seed to soil map, we have this 50, 98, and 2. Each of these three numbers actually signifies different things: the destination start range, and then the source range, and then the range length. So, for example, the first number is the destination range, but if we have a value that, for example, our seed is 98, for example, this would actually point us to the 50 in this case. So, for example, the two values of 98 and 99, these actually correspond to 50 and 51. So, to begin with, this is a little bit complicated to understand, but actually it makes it a lot easier after you think about it. So, the thing to look at is that this under the hood kind of looks like this, where you've updated it from seed to soil. So, if your seed is 50, this means that when you run your function, you need to return a 52, for example. Or if you have a 98, it returns a 50 as well. So there's it's just a different mapping. And then the interesting thing that you have to do is that each of these inputs, they follow each other. So it's from soil to fertilizer, fertilizer to water, etc. And you need to go through this chain of maps to get your output. So in our case, it would go from the seed of 79 to 81 to 81 to 81 three times because nothing changes, and then finally to 74, 78, 78, and the final number is 82. And what we need to actually do to solve our puzzle is find the lowest location number that corresponds to any of our initial seeds. So we have to calculate all of these values for each of these seeds, and then we can get that lowest number. So the lowest number, that's really easy. So how I solve this problem is actually really straightforward and simple. Um, First of all, we'll look at some of the things. One thing to note in this challenge is that you need to use a quite a large number for calculating some of the things later on in the larger file. But there's a couple of things we start off with. So if we jump down to our almanac, this is actually the important bit. So we're taking our input in this case, and we're building up all the things that we need to. In our case, it's going to be a vector of locations. So these are our seeds. And then also these locations where we have a vector of strings, like a vector of tuples, which has a string and a vector of ranges. And ranges is also something really interesting, which is this is actually the bit that we saw earlier around the destination, source, and range as well. The main reason for this is because when we parse it, we can do some string splitting, etc. But we can also add our own implementation called, or our own function called lookup, to do the kind of calculation for us. So in our case, what we're doing is when we have a current location, so if you can imagine our seed value, so let's have a look at the first seed. This would be 79, for example, our seed number. We would pass it into this specific range and do this specific check, which in our case is to make sure that if the current is greater than or equal to the source, so like 50 would equal to 50, for example, or 79 would equal to 79, or we can do also another check as part of this, which is okay, check the end if it's lower than the end as well. So this would be from, in our case, it could be, I don't know, let's have a look at the numbers again for this. It would be something like you look it up and it would correspond to it, and it will return an optional U64, which is just literally the one that is the offset number as well. This allows us that when we run our own little lookup function, what this will do is go through each of the range. You could use an iter here. I just made it really simple with a for loop. And I was able to actually do a quick lookup. If there's something returned, then you want to set the last and then also set like the found and a few other things as well. This is just the calculation to pretty much create a vector of all of these locations, including initially with the seed, and then pretty much just making sure that you push onto the stack the current and new calculated location. And then the other case as well to just like keep in mind is if, for example, nothing is found, you need to push on the same as that you had before as well. So in our case, it would be, that's why you saw, if we go back down here, this like 82 to 82 to 82 means that in those different maps, there wasn't actually something to convert to, for example. And then last thing to cover, which is once we have the almanac, we're going to do a lookup on the specific seed, and then we just add it to this lower list. We double check to see, okay, if the lowest is equal to 0, then set it to the first one. Very simple. And then also make sure, like, okay, we want to do if this is lower than the previous one, then put in the last as well. We added some tests as well, just to make it really simple, because that range lookup was bothering me sometimes with how complex it could be. So I wanted to put in some test code in here just to make it a bit easier. But I would say that this is not necessary, but I think it was easier to understand. And of course, if you run this now, it will generate you all of the vectors. In our case, it will be all these ones. We just saw that before. And then it will look at all of these last numbers to see whether or not that last number is the lowest. In our case, it's 35, which if we look in the sample here, it was. So if we now run this on our full input, so let's just go back down here and we put in full, we can actually run this. It will go over and loop over every one of our seeds, and it will calculate us this number, which is 84 million, which is actually the one in here as well. So thank you for listening. I'm not going to be doing part 2 today, sadly. We can take a quick look at it. And I think the interesting thing about this is that the seeds that we had as our input for the previous versions, now they're actually a pair, where the first is the start and then the end is actually the range length. So the length of the range. So in our case, we need to create a range of the seeds between 79 and 14. And perform the calculations as well, and pretty much the same output as what we had before. So a little bit longer, but it should be relatively straightforward, but it might require a little bit more compute, at least from how I'm thinking of it, especially with very, very large numbers. So I'm going to leave this for today, and hopefully we can solve it in the next few weeks or something. I'll come back to it. So thank you very much, everybody, for joining, and I hope you learned something. Take care.